underwater volcano off the coast of California, and scientists think
A volcano erupted in the Philippines, covering the nearby towns.
The United States Geological Survey USGS has just issued a red alert after satellite systems detected notable magma movement beneath California's Long Valley Caldera, triggering widespread concern among scientists, emergency services, and communities across the region. This caldera, located in eastern California near the Sierra Nevada, is one of the most geologically active and potentially dangerous supervolcanoes in North America. The new satellite imagery and geophysical data point to significant subterranean changes that could herald a major geological event, making the situation both scientifically intriguing and deeply alarming. Before we start, smash the like and subscribe buttons for more updates. Long Valley Caldera is not as famous as Yellowstone, but to volcanologists, it is equally, if not more, significant due to its history and potential for catastrophic eruptions. The caldera stretches roughly 20 miles long and 11 miles wide, formed approximately 760,000 years ago after an enormous eruption ejected hundreds of cubic kilometers of volcanic material into the atmosphere. Since then, it has seen periodic unrest, including swarms of earthquakes. Ground deformation are unlike anything observed in recent decades. What sets this event apart is the clear upward movement of magma from deep within the Earth's crust towards shallower chambers beneath the caldera. Satellites equipped with interferometric synthetic aperture radar INSAR have picked up precise measurements showing inflation of the ground surface, an unmistakable sign that magma is pressurizing the system from below. Accompanying these satellite signals, seismographs in the region have been recording swarms of low-frequency earthquakes and harmonic tremor patterns, both of which are often associated with the migration of magma. While ground deformation has been seen before in Long Valley, the current uplift is far more rapid and covers a larger area than previous episodes. Volcanologists are particularly focused on the rate of vertical displacement, which has reached over several centimeters in a matter of weeks, an unusually fast pace. Additionally, gas sensors in the area have picked up elevated levels of carbon dioxide and sulfur dioxide, gases commonly released from magma as it ascends. These developments have pushed the USGS to escalate the threat level, classifying the situation under a red alert, the highest warning tier reserved for volcanic activity that poses imminent danger. One of the immediate implications of this alert is the activation of emergency response protocols throughout California. The California Office of Emergency Services (Cal-OES) is coordinating with federal agencies to prepare for potential evacuations, infrastructure protection, and communication strategies. While an eruption is not guaranteed, the possibility has increased dramatically due to these recent signs, and the risk of even a minor explosive event cannot be dismissed. Beyond the emergency logistics, the scientific community is racing to analyze the data in real time. Magma movement is a complex process, influenced by countless variables, including temperature gradients, tectonic stress, and the composition of the Earth's crust. The data from the Long Valley Caldera indicate that magma is not only moving upward, but also laterally, spreading into different areas beneath the caldera. This horizontal migration could result in the formation of new fissures or vents, possible eruption points that may not align with previously monitored locations. Geologists are especially concerned about the interplay between this volcanic system and the nearby fault lines of the Eastern California shear zone. The region is highly seismically active, and any volcanic activity could potentially trigger tectonic events, or vice versa. The release of pressure in one part of the system could destabilize adjacent geological structures, setting off a cascade of earthquakes or even landslides. This coupling of seismic and volcanic risks makes the Long Valley Caldera a uniquely dangerous landscape. Long Valley's proximity to populated areas heightens the urgency. Mammoth Lakes, a popular ski resort town, sits right on the caldera's edge. Thousands of residents and tourists could be in the direct path of ashfall, pyroclastic flows, or lahars, depending on the nature of a potential eruption. An ash plume alone, if it reaches high into the atmosphere, could disrupt air traffic across the western United States, creating economic ripples far beyond California. The 1980 eruption of Mount St. Helens demonstrated how even a relatively small volcanic event can paralyze airspace, damage power infrastructure, and compromise water supplies for millions. One of the more chilling aspects of this situation is how silent and invisible the early stages of volcanic awakening can be. Without satellite technology, much of this magma movement would remain hidden from view, unnoticed until surface-level signs like steam explosions or fumaroles begin to appear. The advent of INSAR and real-time geophysical monitoring has fundamentally changed the ability to detect such hazards in their nascent stages. But even with advanced tools, prediction remains a delicate science. Volcanoes don't always follow a clear pattern. Magma can stall, reverse direction, or cool underground without ever breaching the surface. Alternatively, it can erupt explosively with little additional warning. In this case, the sheer volume of magma being displaced, combined with seismic and gas emissions, paints a picture of a system under growing pressure. This is not a minor fluctuation or a benign geothermal hiccup. The energy building beneath the Long Valley Caldera is substantial. Some researchers are comparing the current deformation patterns with those observed before the 1980s unrest period in the same region, which saw thousands of earthquakes and significant ground uplift, but ultimately no eruption. However, current signs are already exceeding those previous markers in intensity and scope. The potential environmental consequences of an eruption at Long Valley are profound. Ashfall could blanket hundreds of square miles, contaminating water sources, damaging vegetation, and impacting livestock. Fine volcanic ash is not just a nuisance. It clogs engines, destroys crops, and poses serious health risks when inhaled. Respiratory issues, particularly for the elderly and those with pre-existing conditions, could spike dramatically in affected areas. If the eruption were to be more explosive in nature, pyroclastic flows, superheated gas and debris surges could devastate everything in their path within seconds. These are the deadliest features of volcanic eruptions, and Long Valley's geological makeup suggests it is capable of generating such flows under the right conditions. Even a small-scale version would be catastrophic if it occurred near inhabited zones. Another major concern is the hydrological impact. Long Valley Caldera is intricately connected to regional water systems, including aquifers that supply drinking water and irrigation for agriculture. An eruption could taint these resources with sulfur, heavy metals, and ash, leading to long-term consequences for human health and food production. The Owens Valley, already a contentious area in terms of water rights and availability, could be plunged into an even deeper crisis if volcanic materials enter its watershed. Transport and communication infrastructure would also be at risk. Highway 395, a major north-south artery in California, runs right through the affected zone. In the event of an eruption, this route could become impassable, isolating communities and delaying emergency response. Power lines, communication towers, and pipelines in the area could be severely damaged by both the eruption itself and secondary effects like landslides or ground liquefaction. Such disruptions could take weeks or months to repair, depending on the scale of the event. In terms of broader implications, the alert at Long Valley raises serious questions about preparedness for volcanic hazards in the United States. While much attention is often focused on earthquakes in California, volcanic threats receive comparatively less public awareness, despite their potential for equal or greater destruction. The current red alert serves as a stark reminder that America's volcanic landscapes are active, dynamic, and capable of producing life-altering events with little notice. This event is also prompting international scientific collaboration. Volcano monitoring agencies from Japan, Italy, Iceland, and Indonesia are sharing data and modeling projections, helping to refine eruption forecasting and response strategies. The geological behavior of calderas like Long Valley is a subject of global interest because these systems are among the few on Earth capable of super eruptions, events that could have climate-altering consequences for the entire planet. While there is currently no indication of a super eruption on the horizon, the fact that magma is on the move at all makes this an important opportunity to study the precursors of such rare but devastating phenomena. On a deeper level, the magma activity beneath Long Valley is a vivid reminder of Earth's inner vitality. Though our planet's surface may seem solid and unchanging, it rests atop a churning, molten underworld that is constantly in flux. When the deep Earth makes its presence known, whether through earthquakes, volcanoes, or geothermal surges, it reasserts a truth often overlooked in daily life. that humanity exists at the mercy of immense natural forces. The red alert at Long Valley has put that truth in sharp relief. The coming days and weeks will be critical as scientists monitor for further signs of escalation. The movement of magma may slow, or it may accelerate. An eruption may occur, or the system may stabilize temporarily. For now, the focus remains on vigilance, data collection, and public readiness. Every tremor, every centimeter of uplift, every change in gas output tells a story, and that story is far from over. As the situation at the Long Valley Caldera continues to develop under a red alert status, a deeper analysis of the surrounding geologic systems and the unique characteristics of this caldera reveals even more unsettling complexities. Unlike stratovolcanoes that build towering cones and erupt frequently in smaller, more manageable bursts, calderas like Long Valley are the remnants of ancient titanic eruptions. Their deceptive tranquility, flat, scenic landscapes popular with hikers and skiers, belies the vast reservoirs of molten rock still lingering beneath the surface. Long Valley's magma chamber, according to seismic tomography studies, is not a single unified body, but rather a network of partially molten rock suspended in a sponge-like matrix of solid crust. This distributed nature means pressure can build in one area while another remains relatively unaffected, complicating efforts to identify the precise location where a breach might occur. It's akin to trying to predict where a balloon will pop based only on watching it expand. Not an easy task, even with the most sophisticated equipment. What particularly worries scientists is the way magma has started to interact with hydrothermal systems. As magma rises, it superheats groundwater, turning it into steam and creating powerful underground pressure that can lead to phreatic explosions, steam-driven blasts that don't require magma to reach the surface. These explosions can be sudden and highly destructive, propelling rock and debris at high velocities over considerable distances. They can also act as precursors to more significant eruptions, signaling that the cap rock sealing the magma may be weakening. The interplay between water and magma introduces another set of hazards. Hydrothermal systems have been active in Long Valley for millennia, giving rise to hot springs, fumaroles, and the region's well-known geothermal energy projects. But when these systems become supercharged by ascending magma, the outcome can be violent. Steam bursts from newly formed fractures can destabilize slopes, trigger landslides, and compromise existing man-made structures designed only for low-level geothermal activity. This brings into question the resilience of infrastructure currently operating within the caldera boundaries. Several geothermal plants in the vicinity, such as those operating in the Casa Diablo area, tap into the same hydrothermal system now being affected by this sudden surge in subsurface energy. These facilities are not only vital for renewable energy supply in California, but also contain pressurized systems and pipelines that, under volcanic stress, could rupture or explode, adding industrial danger to the natural hazard. Another subtle but significant threat lies in the possible formation of new volcanic vents. Calderas, unlike single-vent volcanoes, can open multiple eruptive pathways over a wide area. The porous, fractured crust above Long Valley's magma system makes it susceptible to forming new fissures miles away from the central uplift. This means that a town, a road, or even an isolated wilderness area that seems safe based on current maps could suddenly become the site of a new eruption if the magma finds a weak point in that direction. Current models suggest that the system may be under influence not only from internal magmatic forces, but also from broader tectonic stresses affecting the region. Long Valley lies along a transition zone between the Basin and Range Province to the east and the more tectonically stable Sierra Nevada block to the west. Over time, this area has been subjected to stretching, faulting, and shifting at rates that, while slow on a human timescale, have enormous implications for geologic stability. The recent magma migration might be tapping into these fault zones, using them as pathways to move through the crust. It is even possible that we're seeing the beginning stages of a caldera rejuvenation cycle. In geologic terms, calderas are not dormant remnants, but dynamic systems that undergo periodic phases of magmatic recharging and potential resurfacing. The current magma activity could represent the start of such a phase, a centuries-long process that may include episodic eruptions, continued ground uplift, and the eventual emergence of new volcanic features. Such transformations have occurred before in Earth's history. often with profound ecological and climatic effects. Speaking of climate, a large-scale eruption from Long Valley, even if it's far below supereruption magnitude, could influence atmospheric conditions. Depending on the volume and composition of erupted material, a significant ash injection into the stratosphere could alter weather patterns, reduce solar radiation, and contribute to short-term global cooling. Sulfur-rich eruptions in particular are notorious for this effect, as they release sulfur dioxide into the atmosphere, which then forms sulfate aerosols that reflect sunlight. Even a modest climate shift could exacerbate existing problems in the western United States, a region already grappling with prolonged droughts, water scarcity, and agricultural stress. Crops are vulnerable to reduced sunlight, and ash-contaminated rainfall could impact soil chemistry for years. Such consequences would not be confined to California. They would ripple through supply chains, food prices, and energy markets far beyond the eruption zone. Educational institutions and scientific organizations are treating this moment as both a crisis and a teachable opportunity. Teams from the USGS, NASA, and several university geology departments are deploying mobile labs and drones to monitor the terrain. These tools are collecting high-resolution thermal imagery, gas samples, and real-time seismic feedback to map the changing conditions beneath the surface with unprecedented detail. These efforts are not just for immediate response, but for long-term learning that could aid in future prediction efforts across the globe. Communities near Long Valley are responding with a mix of concern and resolve. Local leaders are holding informational meetings, distributing preparedness materials, and ensuring that evacuation plans are updated and accessible. But uncertainty breeds anxiety. It's difficult to prepare for an event when the timeline is unknown and the severity could vary from minor to catastrophic. Schools, hospitals, and businesses are all conducting readiness drills, balancing the line between being prepared and inciting panic. Meanwhile, insurance companies and real estate markets are beginning to react. Properties located within the projected danger zones are seeing sudden drops in market interest. Insurers are reassessing volcanic risk portfolios, which had previously been concentrated around more historically active sites like Mount Rainier or Hawaii's Kilauea. The possibility of even limited eruption activity at Long Valley is forcing a reevaluation of how volcanic risk is calculated in areas not traditionally flagged as high danger. Tourism, a major part of the regional economy, is already seeing the effects. Mammoth Lakes, which typically sees a flood of outdoor enthusiasts, has begun experiencing cancellations. Trailheads are being closed, ski resorts are operating under heightened caution, and tour operators are fielding more questions about refunds than bookings. This economic pressure is yet another reminder of how interconnected human systems are with the whims of the planet beneath us. One of the more sobering implications lies in the psychological and cultural terrain of living with a supervolcano. For many, the term supervolcano evokes Hollywood-style apocalyptic visions, but in scientific reality, it refers to any volcano capable of erupting more than 1,000 cubic kilometers of material, an extremely rare event. Long Valley qualifies based on its prehistoric eruption, but what makes the current activity unnerving isn't that another super eruption is imminent. It's that the system is waking up, and no one knows yet where it will stop. Living with a volcano like Long Valley means confronting the reality that not all dangers are predictable in the short term. Scientists can estimate probabilities, model scenarios, and advise governments. But a final decision to evacuate, to declare a public emergency, to shut down roads or move entire towns, these are human choices layered on top of deep, unknowable geological rhythms. These decisions must be made quickly, often with incomplete information and always under pressure. Another major point of discussion among geologists is how this event might connect with broader patterns of magmatic reawakening seen elsewhere along the Pacific Ring of Fire. Over the last few years, there has been a marked uptick in volcanic activity across this belt, from Iceland and the Kamchatka Peninsula to the Andes and Indonesia. Whether this is coincidence, correlation, or part of a larger global cycle is still a matter of research. But the timing adds urgency to the current surveillance of Long Valley. The next few weeks will likely determine how this chapter unfolds. If ground inflation continues to accelerate, and if gas outputs increase in volume and acidity, it could point to magma nearing the surface. If seismic patterns evolve into more rhythmic tremor events, it could signal an imminent breach. Alternatively, activity could taper off, marking this event as another intense but ultimately contained phase of unrest, one that adds data to the growing library of volcanic behavior. No matter what happens next, the lessons from this alert will shape how similar events are monitored and managed in the future. Long Valley has become a focal point not just for emergency preparedness, but for deepening our understanding of Earth's internal processes. It's a living reminder that beneath our feet lies an engine of unimaginable power, mostly silent, often patient, occasionally ferocious. Human civilization thrives in the shadows of mountains, rivers, and valleys shaped by fire and stone. We pave over old lava flows, build towns on ash beds, and relax in hot springs fed by ancient heat. But nature never forgets. The awakening of Long Valley Caldera is a call to remember that the ground we stand on is not static. It is alive. And every now and then, it moves. If you like this video, please give it a like and subscribe to our channel. Also, leave your comments below and tell us. What are your thoughts on the magma movement beneath Long Valley Caldera? We want to hear from you. Thank you for watching and see you next time.